Hey there everybody, welcome to class. So today we are going to talk about suspension components and the systems that they fall into. So I think it's best to start off with what the heck does suspension do? Well, it has a couple of jobs. First and foremost, we need to maintain traction, right? That's a safety thing. If we don't maintain traction, we're going to slip and slide all over the place. So our suspension is going to help maintain our traction. It's also going to help us keep control of the vehicle. Again, keeping us safe, making sure the vehicle is going where it's supposed to be going or where we want it to go. And then we want it to be comfortable, right? So rather than be, in a buggy with wooden wheels and no suspension, where you're starting bouncing all over the place, going over a road. Besides our tires absorbing shock, our suspension is actually going to be doing most of the work to make sure that you are comfortable in your car. Let's talk a little bit about the components involved. So we're going to talk about all the components that most of the components that you might find in all suspension systems. There's going to be an exception. This is a basic automotive principles class. So when you get into one of our suspension classes, we'll get way more in depth. But these are the basic components that you'll come across. Springs, of course, when you think of suspension, I think most people think of the springs involved. Now, what is the job of our spring? Our spring is meant to absorb shock, and this is going to be really important because when we get to shock absorbers, I'll tell you a little secret, they don't absorb shock. But springs do. Springs absorb shock, and they are really what is one of the main components that's going to be responsible for making sure that you're comfortable in the ride. We'll talk more about shock absorbers because they work in conjunction with springs to make sure that that happens as well. But springs are also going to be one of the main contributing factors to your ride height as well. Not the only one, but it's one of the main contributors to your ride height and what's going to determine your ride height. Now your springs, no matter what kind of spring, because there are so many different designs, we'll talk about that in a minute, they have two actions. They are either in jounce, which you might know as compression, so that spring compresses, and then we've got rebound. So jounce or compression is when the spring is compressed, the tire is moving upward, right? So you're driving and you go over a speed bump. When that tire goes up and over that speed bump, that tire is being pushed up by the road, and that tire is going to push up our suspension, which is going to compress our spring. Now, when we compress our spring, we have contained energy that is going to need to get released, and so that's what rebound is for. So spring extends, releasing that energy. The tire gets shoved downward. Now, this is going to happen compression, extension, or jounce, rebound, over and over until that energy has been released. Now, our shock absorbers are going to come into play later on to help limit that, and we'll talk about that in a few slides. The different types of springs are as follows, though. When you think of the term spring, when you hear the word spring, what probably comes to your mind is a coil spring, those sort of little coil metal springs that we see in different areas of our life and different components that we use, but definitely in our car, right? And that is one type of spring that our vehicle uses because there are multiple types of springs. So the coil spring is essentially a coil of material, a coil of metal. Your spring's going to be sort of usually a heat-treated metal. Now, and this goes for most of your springs, but coil springs specifically can be linear rate or variable rate, meaning does that spring act the same no matter how it's compressed? So if we're looking at a spring rate, and we'll say for a particular spring to compress 1 inch, it would take 100 pounds. To compress an additional inch, it would take another 100 pounds, and every inch, therefore after, would be an additional 100 pounds to compress it 1 inch. That would be a linear rate spring, meaning it acts the same throughout its entire compression. A variable rate spring might be, okay, to compress the spring the first inch, it will take 100 pounds. But if you want to compress it an additional inch, it's going to take an additional 200 pounds or 300 pounds. And usually the way variable rate springs will go is they will, I don't want to get ahead of myself here because I think I've got another slide talking about this, but they will generally get stiffer as they compress more. But variable rate springs, how do you do that? How do you make a spring act differently the more it compresses? Well, we can either have different diameter coils, meaning I've got skinnier coils and wider coils as it goes through the spring. I can have different coil spacing, and this picture right here is a great example. So you can see we've got a much larger spacing up at the top, and then down here we've got a much tighter spacing where those coils are much closer together, meaning that this spring down here is going to act stiffer, while this part of the spring up here is going to act less stiff. So the more it compresses, the more stiff it gets. And as I mentioned, usually stiffer the further they are compressed. So usually you want a variable rate spring when you want a nice comfortable ride on daily driving, but let's say you want to start taking corners really rough, or you want to start loading up your vehicle so it can carry more weight or something like that. Usually it's a handling thing. When you start to take turns a little bit harder, you're going to get a little bit more weight transfer, so you're going to compress that spring even further. So when you get that weight transfer, the spring tends to stiffen up so you don't get near as much body lean or that weight transferring to your outside. So a lot of your aftermarket lowering springs, H&R, Tane, Ibach, a lot of those companies, when they make lowering springs to go on daily drivers, they'll usually make them variable rate. That way you can keep the nice comfortable ride from day-to-day driving, but when you want to ask something of the spring, it will stiffen up a little bit for you. The next type of spring is going to be leaf springs. Leaf springs are usually found on trucks, but not 100% always. So we've got two designs. We either have a multi-leaf design, which you do see on the back of solid rear axle trucks a lot of the time. They can be found on really old cars, used like possibly pre-70s or pre-70s on some passenger vehicles, but we got rid of that a long time ago because they're really heavy and they're sort of rough when it comes to a ride. And so as technology gets a little bit better and people want more of their vehicle, they want a nice, soft, comfortable ride, leaf springs are not always the case for that, especially with lighter vehicles. So leaf springs are really great with heavier vehicles. They're really great with heavier loads, which is why we see them on trucks an awful lot. But they do ride rough because of their properties. Now, we do have a mono-leaf design that is used on rare occasions. The best example I can think of is going to be your Chevy Corvette, which I do believe the C8 doesn't use it anymore. But pretty much most all Corvettes, besides the new one, is going to be a mono-leaf design. So multi-leaf designs are longitudinally mounted, meaning from front to back. And as the leaf gets compressed, it tends to flatten out. So you'll have a shackle that's going to allow for the length change of that leaf. So if this is sort of my leaf at rest, when it gets compressed, it sort of does this number, and it is going to change length. So we have a shackle to accommodate for that. But a mono-leaf design, say on the Corvette, runs transversely from side to side, and it's only one leaf. Now, a lot of the times, your leaves are going to be made of heavier metals on a multi-leaf design, as to where in a mono-leaf design, they might be using something like carbon fiber or another composite type of material. So it's going to be much lighter. It is a mono-leaf, so it's not going to be, and because of the material, it's not going to be near as rough. It is a design that not many companies use because it's considered sort of old technology and nobody really uses that anymore. But you know what? You can't really you can't really argue when the Chevy Corvette can do a G in the skid pad. That thing handles pretty darn well. And they do it really well with that. However, I do believe they did change from the C8. But anyways, that's the best example I can think of a monoleaf design. The next type of spring is going to be a torsion bar. And this one is the one that really gets everybody because it doesn't look like a spring at all. It looks like a bar. It looks like some sort of support bar, but it doesn't look like a spring. So it will mount somewhere on one of the upper suspension components, usually your control arm, and then in the rear it's going to mount onto a subframe. So as your control arms, and I know I haven't talked about this component yet, but these control arms are going to move like this as your vehicle, let's say you go over a bump and your springs compress, your control arms are going to move up, and then when they rebound, they're going to move down. Well, that end of the torsion bar, I've got one end that's stationary that is on the frame, so it doesn't move. And then the other end is going to fit in almost a keyway in those control arms. So if I had the mount in that control arm, as that control arm changes, my torsion bar is actually going to twist along with that control arm. And I'm going to put some videos in here to in your canvas to hopefully give you some better visuals that I can't really give you because I'm not really great at editing or computer graphics. So you can see sort of how it's mounted. And torsion is a sort of twisting motion. So that bar is made of a special metal that is meant to twist but want to spring load back. And so it does act as a spring. Now, the cool thing about torsion bars is they're adjustable from the factory. So if you wanted to lower or lift your vehicle small amounts, you can actually do that on a vehicle that has torsion bars. Now, with that being said, you don't want to max them out either to lift or lower because you are going to lose travel of your spring as well, and you're going to sacrifice the comfort of your vehicle. Now, to adjust it on the side that is usually mounted to the frame, there'll be an adjustment nut. When you get into a suspension class, we'll talk a whole lot more about that. Air springs, also known as airbags, are a spring. So when you see a vehicle, especially most commonly, we'll see them aftermarket, right? Where you've got like the bagged mini trucks or whatnot. That type of suspension or those airbags act as a spring. So it is an airbag, a rubber material that is filled, in fact, with air. And by the way, that's not just an aftermarket thing. Lots of factory vehicles, not most, but there are a lot of factory vehicles that do come stock with airbags. A lot of, I believe BMW utilizes them, Jeep utilizes them. A lot of the sort of newer crossover SUV style vehicles will use them that are meant for off-road because you can adjust your ride height and you can adjust your stiffness using this, and that's really nice. So you can just press a button and you can put it in off-road mode, or you can press a button and you can put it in a mode that's going to make you a little bit more aerodynamic on the freeway and things like that. If you're planning on driving on ice or rocks, there's all kinds of options for you, and airbags allow you to change your ride height as well as a spring rate with changing your ride height, so stiffness and things like that as well. Now, if your vehicle comes stock with air ride, meaning you can change your ride height from the push of a button, that means that is computer controlled. Meaning that you press the button, it asks the computer, the driver would like to do this to the air ride, and the computer is going to send a signal to either the compressor or some valves that are going to inflate or deflate those airbags for you. Sometimes there are these automatic settings that will change ride height based upon your speed and things like that. As well as it will see potential driving habits and be like, oh, we need to lift the vehicle or lower the vehicle. So here's the problem with that if you plan on working on these vehicles. If it sees a change of height of the vehicle while your tires are lifting up off the ground, right? So your suspension is changing because you put the vehicle up on a lift or on a jack. It may inflate the bag and inflate to compensate more and more and more. And especially on older systems, and even potentially newer systems, it may inflate the bag so much to where you'll blow out the bag. On factory vehicles, that can cost you $1,000 for just one of those suckers, or $800. They're very expensive. So if you're going to work on one of these vehicles, even if you're just doing an oil change and you want to lift the vehicle up on a lift, you need to disable the air ride. Either that or go in with a scan tool and use some bidirectional control to disable the system and put it in like a maintenance mode or something. But you can pull the fuse for the air ride. You can disconnect the battery. There's a number of ways to do that, but you need to disable the air ride on that vehicle before you lift it up because it doesn't know that you put it on a rack. It doesn't know. It's just trying to compensate for seeing changes in ride height. Now, the diameter of the bag itself and the bag thickness or the thickness of that material is going to determine your spring rate as well. So if you're looking at a set of aftermarket bags, that's something to look into. However, aftermarket-wise, a lot of people will put airbags on and they will remove the shock absorbers and not put them back on. I always recommend you're going to need to make new mounts for shock absorbers because these are springs. They're not just springs and shock absorbers, and so they don't do the job of a shock absorber, and we'll talk about that in a little bit here. Bump stops. So there's two components that really do the same thing. They just happen to be located in different areas, and that is bump stops and jounce bumpers. Bump stops are going to be something like this, where it's located on the frame, and it's usually this sort of rubber-looking mountain piece here. It can be It can be angled, it can have a step where it's variable rate, but what we don't want to do is we don't want the vehicle to bottom out on the frame when the vehicle suspension is fully compressed. Let's say you're going over a really hard bump or you accidentally jump the vehicle and you slam back down. You don't want the frame to come in contact with the vehicle, so you put in a bump stop on the frame. A lot of people who lower their vehicles will shave these down so you're not bouncing on the bump stops a whole lot. It's always recommended to at least keep a bump stop rather than completely remove it because it does have a job. Now, jounce bumpers do the same thing, except they're usually located on either McPherson struts or the shock absorber, and they look like these sort of styrofoam. They almost look like dog toys. They're sort of these ribbed rubber pieces that allow your suspension, like a McPherson strut, when it completely compresses, it can bounce off of that jounce bumper, but they do the same thing as a bump stop. They're just located in different areas. Shock absorbers, and I've been saying this term over and over again, and now I'm excited because we're finally here. Shock absorbers do not absorb shock. That's not their job. The job of the spring is to absorb shock, which is funny because we call them shock absorbers. I didn't make this name up, but it's an industry term. What do the shock absorbers actually do then if they don't absorb shock? They limit or dampen the amount of spring oscillations. Well, that sounds super fancy, doesn't it? When your spring goes through jounce and rebound, it doesn't just jounce and rebound and stop, right? When you think of a spring moving in action, you get that sound in your head, right? That boing, boing, boing. That sound comes from spring oscillations. So when I compress a spring and then release it, it is going to go through its motion of compression, rebound, and it's going to do it less and less and less and less until it's done and it's got all that energy out. So if I had no shock absorbers and I was driving my car and I went over a bump, it would not just continue on straight. I would go over that bump without shock absorbers and my car would keep going up and down, up and down, up and down, going and going and going, and less and less and less until it stopped, which you will notice in a lot of vehicles with aftermarket air ride. tend to do that. Why? Because they didn't put shock absorbers back on. And that's what shock absorbers do. So when you go over a bump, your shock absorber's job is to make sure that my coil oscillation is minimized and can stop so I can continue driving and maintain control of my vehicle. So we're dampening the amount of times that spring's going to oscillate, or we're going to limit the amount of times that spring oscillates. So that term oscillate is referring to jounce, rebound, jounce, rebound, jounce, rebound. And we're doing this usually using some sort of fluid going through a valve. So I've got a tube and a piston that's moving through this tube that has fluid in it. So that piston moving through fluid is going to slow down that jounce and rebound and jounce and rebound. Now they do make gas charged shocks. This is so in the shock absorber, I'm going to have fluid. And that fluid, if I have a lot of jounce, rebound, jounce, rebound, jounce, rebound, or compression, rebound, that movement in the fluid can cause foaming. And we don't want foaming or what they'll call oil dissolve, where we get a lot of air pockets in there. So what we'll do is we'll put a gas chamber in here, usually nitrogen gas of some sort, and it's actually going to pressurize that fluid so it keeps it from foaming, and if it does build up air pockets, it can push those air pockets out. And that's really the main design of our gas charged shocks, is to limit the amount of dissolve or foaming of our oil or fluid. Now, a lot of aftermarket shock absorbers can be adjustable. And there's a number of ways that you can adjust. You are either going to, there's going to be some sort of knob of some sort, and really what you're doing with that knob is you are changing the valving, that piston that's moving through that tube of fluid. You're changing the valves of that piston. So there's little tiny holes in that piston that are going to allow fluid to transfer from one side to the other, because if there were no holes, it would just stop. That's a whole nother topic we'll get into when we get into brakes. But that piston's going to have holes that's going to allow fluid through, but it is going to slow it down. What the adjustable shock absorbers do is you change the size of those holes. The larger the holes, the easier fluid travels through, and the easier that shock absorber is going to compress. The smaller those holes, the harder it is for fluid to travel through, and the harder it is for that shock absorber to compress. So a lot of times shock absorbers may be able to adjust compression and rebound separately. So maybe you need a stiffer rebound and a softer compression, or vice versa, and you can do it with that. Now, newer, fancier shock absorbers can be, and this is from the factory in a lot of vehicles. Cadillac, I believe, uses this, and a lot of other manufacturers are starting to use magnetic fluid. And I believe I've included some videos in your Canvas on this. But what you can do is apply a current of electricity to this magnetic fluid, and you can change the thickness of the fluid. So that piston's still moving in a tube through fluid. But if you change, instead of changing the valving, you change the viscosity or the thickness of that fluid, that piston, if it's a thick fluid, is going to move harder, it's going to resist movement more than if it's a thin fluid. So you're able, using electricity, to change the viscosity and stiffness of your compression or rebound. So that is super duper cool. Like I said, I'll send you guys some video links for that. But that allows you to press buttons inside your vehicle and change your compression and rebound of your shock absorbers simply by the push of a button without even getting out of the car. Or even computer control. Let's say I put my car in a certain mode. It sends a certain current through that shock absorber and does that for you. Now, a McPherson strut. A lot of people will use terms like shock absorber and strut synonymously, and they are not the same. They do the same job, just like jounce bumpers and bump stops, but they don't, they're not the same exact type of component. So a McPherson strut is functionally the same as a shock absorber. However, they are not interchangeable from vehicle to vehicle. A McPherson strut, you can see here, is actually going to provide structural support. It's bigger, it's larger, and it's stronger. And most of the time, not all the time, but most of the time, your McPherson strut's also going to include a place for your spring to sit as well. In this picture here, you can see that I've got a control arm down here, and I know I haven't talked about control arms yet, and up here I have no control arm. My McPherson strut is the only thing that's keeping my suspension from coming in or out, or as my tire moves through its arc, from pushing my suspension in. So my McPherson strut has to be strong enough to hold that upper portion of the suspension. So it does provide structural support. Like I said, the spring may or may not be mounted on it. Ford uses a design where they have McPherson struts that don't have a spring on it, but I will say 90% of the time, your McPherson struts do usually have a spring located on them. Here's a picture of both. So I've got some shock absorbers here on the left and then a McPherson strut on the right. So you can see physically they do look differently. On the right, I've got and I'll talk about more in a little bit here, but an SLA system where I've got an upper control arm and a lower control arm. And my shock absorber is going to sit in between those. And where my McPherson strut design, I've got a lower control arm coming off the frame here, no upper control arm, and I've got a strut instead that's providing me structural support. So the suspension system that uses a McPherson strut is a little bit different as well. Now, I've been meaning to get into control arms because I keep talking about it, right? So control arms are what is keeping, when I've got my tire attached to my hub assembly, what is keeping my tire from moving inward or outward? That is your control arm. So if you look down here, I've got a shock absorber actually mounted to my control arm, usually mounted to your lower control arm. Here is a sort of subframe assembly here. So I've got my control arm that's going to be mounted on one side to the frame and on the other side to my steering knuckle and hub assembly out here. So as my wheel moves up, my control arm is going to sort of teeter. Now, some vehicles have an upper control arm. Not all vehicles. It depends on the suspension design. But I will tell you that pretty much every vehicle I have ever seen in my life does have a lower control arm. I'm not saying that there's no vehicles that don't, but I don't think that they exist. Show me one that does. But pretty much most all vehicles do have a lower control arm. Now, these control arms can either look like this, where I've got two mounting points. I've got one on the frame and one on my steering knuckle. Or I can have three mounting points. We'll usually call these A-arms or wishbones. So they look like this, where I've got two mounting points on the frame and one mounting point on my steering knuckle. The advantage to that is you have a triangulated design. Oops. So if I've got a control arm that looks like this, not only do I have in and out movement control, so my wheel's not moving in and out, but it's also not moving forward and rearward. So I do get a little bit more control with an A-arm or wishbone that has three mounting points rather than two. So you can see here, I've got A-arms or wishbone design where I've got an upper control arm. Here's two mounting points. Here's my third, and my lower control arm with two mounting points on the frame and a third there as well. Now, strut rods are going to be for control arms that are not triangulated. So let me sort of go back here. This control arm design right here is in the rear, but if it was in the front, and I'll get more into rear suspension in a little bit, this control arm only has one mounting point here and one mounting point here. So it's going to keep my wheel from moving inward or outward, but it's not going to control it from moving frontward or rearward. So we're going to need an extra component that we call a strut rod. So this would be sort of from the top, a bird's eye view. We're looking down on that two mounting point design. Here is my inner mounting point that's going to mount onto the frame. Here is my outer mounting point that's going to mount onto my steering knuckle. So what's going to help keep that wheel assembly from moving frontward or rearward is going to be this strut rod. A strut rod is going to mount to the frame in the front, toward the front of the vehicle, and it's going to mount inside that control arm. And so now you can see we are actually that this whole purpose of a strut rod is going to be to help triangulate a control arm. And you can see I've got a picture of one over here as well. But it keeps the suspension system rigid on certain designs. Not all vehicles have strut rods. Now, I keep using this term steering knuckle. A steering knuckle is going to be where your hub assembly is mounted, where your brakes are mounted, where your wheel is going to bolt onto, essentially. But the reason why we call it a steering knuckle is because we need your wheel to be able to turn, right? If I'm turning my wheels, well, I'm going to need something that's going to be able to pivot. So here are my control arms, and here is this knuckle. So in yellow, this knuckle is going to be able to swivel back and forth so your tires can turn back and forth. We call this a steering knuckle. Now there are different designs. If we're looking up here, this is generally a front wheel drive design, but you can see it on many different vehicles. It really just depends from car to car. Where I have my hub assembly and the knuckle all in one. Down here, I don't have my hub assembly. This is simply a steering knuckle. Up here, you can see where it mounts to our control arm, but we can't see the control arm. Down here, we're going to mount to a steering suspension arm. That's called a tie rod. I haven't got to that yet. And down underneath here, we've got our lower control arm that you can sort of kind of see here. Now, you'll notice from the top knuckle to the bottom knuckle, I have this sort of piece that hangs out, this sort of finger that hangs out on this one, but not this one. They call that a spindle. On vehicles where the hub assembly is inside of the brake system, inside of your rotor, and not inside of the knuckle, you're going to need a spindle for your hub and brake assembly to slide onto. So you'll notice I don't have lug studs on this one because my hub assembly is not on this one. A lot of trucks, not all, but a lot of trucks will use this design on the non-drive wheels. So let's say on a Chevy S10 where it has a solid rear axle and it's a rear-wheel drive car, on the front I might have knuckles and spindles that look like this. That's a very, very common design, and we can even talk more about that when we get into brakes. Those are called fixed rotors rather than floating rotors. Now, what allows the steering knuckle to pivot back and forth, because it can't be harshly mounted to those control arms, we need swivel movement, right? Well, what allows your arm to swivel like this? Your shoulder, right? Your shoulder is a ball and socket joint. So it's got a socket and a ball that fits in that socket, which allows a swivel action. Well, your car, your steering knuckle has ball joints and a ball and socket joint on the upper control arm and the lower control arm to allow that. Now, like I said, it connects your steering knuckle to the control arms, but this component right here is what's actually allowing that swivel action so your tires can turn. Some ball joints are serviceable and they have a little grease fitting so you can fill this full of grease. Others, they're sealed and you can't. So when they go bad, you just need to replace them. There's a bunch of different designs, and in fact, we'll get into loaded and unloaded ball joints and serviceable and unserviceable ball joints when you get into a suspension class. Here's some more examples here. I've got a control arm. There's my ball joint down here. Here's a much closer picture of a control arm, and there's our ball and socket joint. You'll notice that pretty much all the time, those ball and socket joints are going to have a rubber boot around them to protect them from grime and grit getting in between that ball and socket joint. I just want nice, smooth grease, right? Because once I get grime and grit in there, I wear out this joint, and now that ball can come out, and that's probably the worst case scenario, so we don't want to do that. One of the later components to those control arms need to be able to move up and down, right, with your wheel travel. Well, those swivel, or I don't want to use swivel because that's a ball joint, that action of moving up and down is allowed by another type of joint, but we don't want metal on metal contact. Just like with any of your joints, you don't want bone on bone contact, right? You want a buffer in between. Well, your car's suspension components, like your control arms, even your shock absorbers where they mount, most of the mounting points for your suspension components are going to have bushings. So when you hear the term bushing, usually, not all the time, but usually it's referring to a rubber joint that is keeping metal from contacting other metals. When those rubber joints go bad, they'll start to crack and break apart, and you'll get clunking when you go over bumps or when you turn, or when you go on a driveway and uneven surfaces, and you'll get this clunk clunk. That's usually because you have bad bushings, because metal is contacting where it's not supposed to. It's just like when you have joints that aren't good anymore and you got bone contacting bone. It's kind of the same thing, but it's usually used where components are attached to the frame a lot of the time, or one component's attached to another, like a shock absorber on a control arm or something like that. These bushings also do help absorb road shock. And then I believe one of our last components that we'll talk about here is going to be your stabilizer bars. We know these as sway bars, or anti-sway bars, really. A stabilizer bar, its main job is to prevent body roll. So when I go to turn into a turn, so if I'm turning right here, my weight of the vehicle wants to transfer to the outside of the vehicle. Well, you don't want that to happen if you're trying to maintain as much traction to the ground as possible. So a stabilizer bar is going to take that weight transfer and it's going to try to put it back on the inside. It's essentially transferring that load to the inside or opposite spring when we get body roll. So if we're looking at a sway bar here, usually we're going to have a sway bar and they're going to include end links. So if we get a closer look here, we've got these tiny little links that either have bushings or little ball joints in them. And that sway bar is going to attach from one lower control arm. I'm going to have two bushings that attach to the frame here. And it's going to attach to the other side's control arm. So essentially your sway bar looks like this. This side's attached to this lower control arm, this side's attached to this lower control arm, and when you go through a turn to transfer body weight, you get almost a torsion action of your sway bar, and it's going to transfer load from one side to the other. So if those sway bar end link bushings or joints go bad, guess what? You don't get that transfer anymore and you're going to get excessive body roll. So if you're driving your vehicle and you're starting to notice, man, I'm getting a clunking and my vehicle just leans so much more than it used to, check out your sway bar end link bushings or joints because they're probably bad. Now, one of the last things I'll talk about before I get into the next video is going to be sprung versus unsprung weight. This is a term that gets thrown around a lot. You want to buy a set of racing wheels. Why do you want to buy a set of racing wheels? Well, because they're lighter. Lighter is better. Why are lighter wheels better? Here is what the reason for all of that is. It's sprung versus unsprung weight. So sprung weight is any component that's supported by the spring. So any weight that's essentially being supported by that spring in your vehicle is considered sprung weight. Any weight that's not supported by the spring is considered unsprung weight. And I gave you guys a little picture here because I felt it was a great representation. You can see on this side, we've got a lot of, actually let's look at here, a lot of unsprung weight. So heavy, the heaviness of the vehicle is on the wheels, and our springs are supporting just the person in a little bit of sprung weight. On this side, I've got my unsprung weight down here, and most of our weight is sprung weight. This person is going to have a much more comfortable ride, and they're going to get, as far as handling goes, you're going to get better handling as well. So components that are unsprung are going to be wheels, tires, brakes, and axles. It's all of that extra weight that's not supported by the spring is going to determine your reaction force or what you feel back into the vehicle when you are going over any type of surfaces. So that's why you want lighter brakes. That's why you want lighter wheels and tires, so you can reduce the amount of unsprung weight that your vehicle has. I gave you guys a video in your Canvas that's got much better visuals, so I highly recommend that you guys watch it. And in the next video, we'll talk about suspension designs and how all these components we just talked about and how they work together. So I'll see you guys in the next video.